from a de-identified data set that's publicly available.
What's it called?
Mimic 3.
Mimic.
Yeah.
Thank you.
Yeah. Are you looking for it?
No, this looks very interesting.
Oh, yeah.
What model is doing the reasoning, the medical reasoning?
So we are using the normal OpenAI model. Yeah. So for that reason, we are using context as much as possible, and that's why we are accessing the actual ICD codes and then making the suggestions on what it should be. But of course, we need to make sure there is guardrails as well. At the same time, I think this is a co-pilot, so it should be used along with an actual coder as well.
Okay. Cool. Thank you.
Okay, that was Medicode, a compliant company. Digital Clone, you are up.
Okay, so doesn't everyone wish they could just go and chill at a beach where they have a digital clone that can go and do all their work? Well, so I decided to build one, and we had Sarma, who's not here, and Harrison, who's the Rendition expert, helped us fix some issues. So okay, so what I did is I took this photo from my website, so I took this single photo, and the resolution is not that great, but yeah. And then I put this to sort of like a face animation AGI, so this is from a single photo. And it's the app, so I can use speech, and I can say something, let's see. What is 2 to the 30th power? Okay, not bad. And so this is using the script, and then I can basically ask myself,
The answer is 27487790694.
how about it? Yeah, and you can also further connect this to like the American API, so then I can basically have my virtual clone do my work, I guess. So let's try that. So if I say, what's the weather in SF? Okay, oh, this is a bit. And yeah, and let's see what happens. So yeah, let's see.
It looks like it's partly cloudy in San Francisco right now, with winds of 15 to 25 miles per hour and a humidity of 84%.
Yeah, so I keep on not using level nuts, but if I use level nuts, it'll be even better. And what I've been thinking is probably maybe for the next hackathon, I can put my digital clone on my website, so if anyone goes to my website, they can interact with my digital self. Thank you.
Can you do behind the scenes on, just talk about the lip sync, the video, the image floating,
Yeah, so I'm using this service. So it's called XHuman. So it's pretty good at doing this like face animation, lip syncing stuff. Yep. And other words, currently using like some Azure voice APIs, and you can also use 11 Labs to make it more realistic. And otherwise, there's like OpenAI and a bunch of other stuff. Cool.
Any more questions for Dick?
Oh, so it's just manipulating the face, it's not generating the video?
Just generating like a face, like an animation around a single image. So it's doing some animation on the lips and the eyes and sort of making more lively. Yeah.
Okay, congrats. Okay, this is Rendition. Rendition is going to talk about using AutoGPT to create UI components from the Figma designs.
All right, hi everyone, Robert. This is Bernardo, and we are building Rendition. If anybody has ever stared at a Figma design, really annoyed by the necessity to write code for it, we are here to help. So right now, and you may have seen it config, table stakes is code from Figma designs. You can get something pretty basic out of Figma without too much difficulty. we're talking divs and images and things like that. But for a really responsive and interactive component, we're still kind of out of luck when working from Figma. We have to do that work as devs ourselves. And so for clarity, we came into today with the capability of writing divs and images based on a Figma design. But these are largely not responsive, not interactive components. And so that is what Rendition is focused on. If we can get the Wi-Fi to work for us. Let me try switching networks here. Okay, so based on this Figma design, we're going to choose the element we want to compile. And it's going to really work on uploading those assets into the cloud for us. We're working with one bar here.
I can't state my effort, I'm sorry.
Alas, we may have to go from a pre-baked demo.
Can I lower my art?
Yes, you can. Thank you. Okay, so I will instead show you what I did when the Wi-Fi was working for me. We get a GPT summary and a couple of options of what we can do. So it's now going to recommend taking a look at the code and saying, here's what we think you should do to improve this. And a couple things is like, oh, this is a drop-down component. So add a selected state to manage the selected option, display it as a button, improving the interactivity, show some options beneath it, and then we can have GPT write the code for us. It's going to stream this update in, and then we can both iterate on it through chat or editing the code ourselves. We're going to get something that's going to be a lot more interactive than it starts out. Now this is a humble dropdown, but Rendition can actually handle pretty much arbitrary Figma designs. So we can take a larger section like this for cards, or even an entire website. The current constraints on this are the context window of GPT and also just kind of the working memory of how large of a component it can operate on without, frankly, kind of screwing stuff up. So that's a little bit about Rendition, and actually does work. So if anybody wants to check it out later on, would be happy to connect. Thank you very much.
Go ahead and send a video to the hackathon. Deep Thinking agent is up. Okay, so if you're curious about any code that I present here, it's all up online in the collab that's linked in the spreadsheet. So yeah, I was very busy today and did not have very much time to hack. So I threw something together in a super short period of time that may make you think, oh, Jeremy must be really ashamed of how simple and quickly written his product was. But no, actually, I think it's really cool. So yeah, there's no serious front end, but this is what I call the deep thinking agent. I've long been interested in what I think of as sort of wisdom patterns. So I have this document called Wisdom Language Patterns, and it's about the kind of thinking processes that wise people use. They tell you to emphasize questions over answers. They tell you to replace the underlying assumptions behind your thinking. They tell you to embrace paradox and contradiction, or understand the ways in which the categories that you're using are flawed. And I thought it would be wonderful if I baked all of the wisdom patterns into an epic prompt that basically would ask about the reframes for the problem that I was working on, about the assumptions that should be unmade or inverted, about the paradoxical truth or contrarian truth behind the kind of question being addressed, about social solutions to problems, about how the asker of the question probably has some underlying motive that has not been explicitly stated and should be understood by the model. And I call it a TFT agent, so it's a tool for thought, and it basically lets me give it a simple original question, and it just sort of recurses on this epic question prompt, attempting to answer the deep questions that it poses to itself. And then when it gets a really high quality response, it pops that response out to me. So I asked this agent, how do I run a great AI hackathon? And there's a super simple initial response, the sort of classic, stock, boring, but still very useful GPT-4 response, which is it'll tell me to define a purpose and goal and choose a theme and set a date and kind of logistics. Okay, we're all accustomed to how valuable GPT-4 can be on that basis. But the deep thinking agent asks a new question. It asks, what are the key elements that make conferences, workshops, or competitive events in other industries successful, and how can we adapt these elements to enhance the AI hackathon experience? What a great question that I would never have thought of. And then it says, well, you need engaging content, clear objectives, interactive sessions, networking opportunities, a well-prepared agenda, and attendee experience and supportive staff. And I was just like, kind of, okay, this is a great question, but the response isn't that magical or dramatic. Come on. But then it asks another question. How can the AI hackathon experience be furthered by incorporating novel and engaging activities or challenges not typically seen in traditional conferences or workshops? And now the answers get interesting. So AI-themed gamification, cross-disciplinary collaboration, AI debate sessions, interactive workshops, virtual and augmented reality experiences, reverse pitches, AI mentor matchmaking. Great idea. Flash talks, okay. But basically, it starts generating much higher quality ideas, and then it asks itself another question about the assumptions behind participation and engagement, and it develops a version of the hackathons for non-technical people, and it talks about changing the primary goals of participants and changing the schedule, et cetera, et cetera. So basically, this agent is going to systematically question everything that a hackathon is about and output totally creative ways to run these things. And so, yeah, I present to you the deep thinking agent.
What was the original, what did you feed it first? The
A
question?
single sentence question, how do I run a great AI
How do I
hackathon?
remember it?
I'm wondering, have you tried like asking to evaluate and then further improve based on that? So form this kind of like self-iterating process for improving the thoughts?
Yeah, so I did implement a super simple evaluation, which was for termination. So it ends when it decides that a response is groundbreaking or profound. But you certainly could actually just continue to work at it.
Well, how do you define groundbreaking or?
Yeah,
Can you show us the end?
so it's not in this notebook, but if you go to the collab after the fact.
What was your key insight?
Yeah, so I guess, in this case, I thought the fact was super high quality, but in this particular notebook, it's not.
Does it do only one question at once, or can it go branch out into like multiple questions?
Yeah, so I was just feeling particularly lazy, so I didn't basically have it ask 10 questions and have the 10 answers lead to like 10 more questions into sort of this like 100-page document on how to run hackathons in all sorts of creative ways. Yeah, so it's a closed loop that terminates, but actually, if I was serious about the problem plausibly, I would just scale out and just search the entire space of possible hackathons. And, all right, last question.
You mentioned mathematical reasoning in the beginning, so are you thinking about using this thing? How they improve it?
Oh, okay. I guess mathematical reasoning. I don't think I mentioned it. I think I just mentioned the wisdom language patterns as being inspiration. But I think, the mathematization of thought is like a plausible prompt where I ask, inversion is one operation, addition, subtraction, whatever. You could use these as tools for that. But that's it. So mathematical research agent is maybe that's what you're thinking about.
Our goal was to build a mathematical research agent. So that's a machine which, when you turn it on, goes and automatically produces interesting novel mathematics. That is to say, it's a machine which takes in electricity and spits out theorems, no human effort required. Obviously, this is very ambitious, and we didn't actually do that over the course of the hackathon. But we tried to figure out what the major problems in creating a system like this would be, what kind of the next steps might be. We think there's two core parts of building a mathematical research agent. The first is finding interesting problems, and the second step is solving them. Most people who are working in AI research today are focusing on this second piece, right? How do you actually solve interesting mathematical problems? This is your people who are building things like automatic proof generators, like folks at Google Blueshift or the team that worked on GPTF at OpenAI. There is a second problem, though, this find interesting problems. And people tend to focus on the other problems, solving problems, because it's much easier to define, right? There's this big question of how can we measure whether a math problem is interesting, much less measure whether our language models are capable of coming up with interesting mathematical problems. So what we did is we scraped a data set of 360,000 interesting integer sequences. Right? So these are sequences that are published in mathematical papers or mathematicians explicitly cited in their work. And what this lets us do is see, well, do large language models have a similar notion of what sequences are interesting to the notions that mathematicians have? And if they do, then we can say, yes, these language models can come up with interesting problems on their own. And if no, they can't actually identify these sequences on their own, that means that there's still gaps in what actually these large language models can do in terms of coming up with interesting problems. So this data set consisted of a bunch of sequences. For example, like the Fibonacci sequence, where you have a series of numbers, it's defined by a formula. You can come up with a program to create those numbers. There's a bunch of mathematical papers which are citing this particular sequence. There might also be comments on like why this is an interesting sequence. And then we looked at whether GPT-4 could actually distinguish mathematically interesting sequences from completely random sequences of similar length, right? So you might look at the sequence 1, 1, 1, 1, 1, 4. And you and I we're probably not going to think of that as super interesting. And yet, this occurs 9 times in this data set of mathematically interesting sequences, primarily because of the structure of trees. So there's a number of problems involving tree-based structures, where the first, the only way in which you can create a tree is, there's one tree of length 0, there's one tree of length 1, one tree of length 2, and then trees of length 4 and more for the other systems, right? So sufficiently competent mathematicians should be able to cite that sort of thing. We show that essentially this is a huge bottleneck in creating a mathematically oriented agent. Like GPT-4 has extremely low recall on this data set. It just has no idea what is mathematically interesting. It thinks nothing is interesting. And so we've created a data set to essentially identify this problem and then hopefully help people fix it by training on these mathematically interesting problems.
Have you tried increasing the length of the sequence? Like, what length of subsequence?
So we use subsequences up to length 64, and you still have relatively low recall across sequence length.
But if you make it like 1,000 or 100,000, at some point does it work? Or?
We could try that. Like if we ran the programs, we could generate additional points in the sequence. But we didn't generate additional points in the sequence. We just took like pre-generated sequences.
Oh, from
and it's got the max length of 64. Yeah.
How many of your prompts just not good enough?
That's also definitely a possibility. We just asked it, is this a mathematically interesting sequence, right? So, definitely do, anything you can give a chain of thought, probably do better, right? But that's part of the things you have to, research to actually figure out, is there a good system?
Thank you, Jordan. ByteFeed News. Talk to me about your 24/7 live broadcasting of latest news.
Hello, everyone. So we're excited to present to you a new type of news experience, a type of news experience that never stops playing. It is 24/7, run by agents. It's run like a traditional newsroom, where every single role that you would normally have in a newsroom is performed, except that it's all done by AIs. So August will take you through the code base really quick, and we'll talk about what kind of logic we created, and then we'll give you a quick demo.
Okay, so the main thing that we did here was put together this class-based agent framework, which pretty much just makes it easy for us to add in new agents and then throw it in to the main loop. So to go through how this is all set up, we pretty much just have these config files for each of the different agents. So when you want to throw in something new, you just go to a YAML file, you give the system prompt, you're able to give a few-shot prompt. We're doing this with the functions API, so You can also set that there so we know what output we're expecting. And then each agent has its own class, which the base class is this one agent class. And then what we do is we have this main function where we actually initialize all of the different agents. So, and then we can show our main thing that's actually happening, and then we'll do a demo. But if I go to this file here, so we get the feeds from an RSS feed, and for now we're just doing it with BBC. We get the feeds, we pass them to the sorter agent, which then will go and decide the top articles to then go deeper on. Yeah, we're going to start it and then walk through the process as it's happening. So we're going to see the outputs that are going to come up in the terminal. So yeah, we start with the sorter, we find some articles, and then when we get the headlines, we're going to actually, so there we go, we're going to pass that into the pitcher, which is going to make a pitch for each of the top 3 articles, which will then pass that into the judge, which will pick the best one, and then the scripter is going to make a script, and then it should start talking.
ByteFeed News, the global news network run by AI agents. Our 24/7 live stream is starting now. Bella, have you heard the news? Zarnell
It's hard to hear.
shattered Linford Christie's British men's 100M record.
No way, Arnold. That record stood for a whopping 30 years. Hughes must have been faster than a cheetah on roller skates.
He clocked an incredible 9.83.
So we're not sure how much you guys can hear, but it's talking through the script. And then what's happening here is it's actually going through the same process, getting the next article, making a new script for it. We'll make a transition between the scripts, and then continues and just keeps talking about the next one. So this can just keep going. And it's hard for the microphone to pick it up, but they're talking over here.
Sportsmanship.
Can you guys hear it all?
Yeah. It's like passing the torch from one sprinting legend to the next.
So that's the main thing.
Thank you. We'll put it on Twitch if you want to watch it sometime.
Yeah, just curious, what do you guys use for the voice TTS? Because that seems really good quality.
So we're just using 11 labs, and then we're streaming the audio, and then we're just like queuing it and playing each Bytes object as we get it.
All right, let's hear it. Agent Snake, the game of Snake where AIs as NPCs, you're up.
Cool. So I think most of us have played like the Snake game before, so we thought about doing something similar with. Has anybody done like the live stream Voyager, like Voyager before? And there's another game like. So if you guys watched Twitch before, you might have seen like a huge video where like the audience sends a bunch of commands. So like who's ever controlling like the game to just like do that command. So we thought about doing this a little bit more in an automated fashion. So. There's 2 ways we kind of thought about doing this idea. So we thought about using an LM to generate the actual game itself. So we used like the Snake game as a kind of like example for this. And what the audience is able to do is like you can tell the controller to just generate more agents into the game. So Snake game, you just have one player, it's just a single snake by yourself. But what we thought about doing is like you can ask the audience to generate multiple snakes. So you can have like agent snakes that kind of go against you, and also the food as well. So, like to give a little bit more context, for example, on Twitch, you have like a bunch of people just sending a ton of commands of like what the thing should do. We thought about doing something similar, but instead of like giving commands of like what the agent should do, we kind of gave it just a single command of what the behavior of the agent should be. So right now here we don't have like any specific behaviors for either of the agent snakes. So we can one second please load. Their only goal is to just eat as much food as much as possible. But the idea is like you can type like you can try to like mess with the human player. Like, hey, make the agent snake try to box in the human player.
here is a little. Okay. So here's one. Okay. So we tell GPT to write a little script to generate, to make the snake go in a certain way. And this is actually live coded, so I can just open the Python file and enter what GPT just wrote into it and save. And it will react. The snake is now drawing a rectangle. And I can go back into the source code and modify the parameters a little bit, and then the rectangle now is skinnier or fatter. And so imagine, well, go to the next demo. This demo shows that GPT just on the fly opens the project and for a 2-player snake game and changes it into a 3-player snake game. What does it do?
So now you are given the instruction to change it to 3-player, and then GPT-4 will modify the code, and then generate the new code. You copy the code, and then put it here, and then it will generate a 3-player snake game.
Hopefully this time it goes faster.
Yes, sir.
We were like 30 seconds before we got here.
Should have used C++.
Should have used C++.
Look, in a snake game, we have to use Python for the time.
That's true.
So right now, both of the agents are just going after the food. But by example, you say you type go after the player as a string. You type go after the player as a string. So it's gonna make the big also go after the player now.
Oh, you're calling the GPT-4. No one is doing that one. Yes. It's actually changing the code.
So now it's trying to.
You are the green player, by the way.
Yeah.
The yellow player is basically the agent that is just written by. It's ridiculously good because it's got perfect reaction.
So basically the idea is like have an audience just tell the needs other agents like what to do against the player, and this would make like a little more of an interactive like audience experience for like these kinds of like agent-based games. Yeah, that's pretty much it.
Very cool. Okay, one question.
Is this using Voyager?
Sorry, louder.
Oh, is this using Voyager?
Oh,
is this using Voyager?
No, this is just using ChatGPT just to look at like where the snake is at the time, and you can specify like what you want to do as like an action.
So we call it Voyager because we think the basic idea is very similar to Voyager. So Voyager is got a skill library. The skill library is written in JavaScript, and here we basically got its own skill library, and the skill library is in Python. The LLM writes the skill library plays the game.
I can just keep moving. Sure, for one. Okay, automated Convo evaluation. You are up.
All right, good evening. I'm JD. This is Ryan, Brian, and Bassam. And you saw earlier in the evening some of the need to evaluate conversations that agents are having and agent performance in general. So that was on the timing side of things and whether they're able to accomplish a task. This is on the quality of the conversations that they're having, which is important if your agent is a therapist agent or a coach or in this case, in our demo, kind of a travel agent. And so when you release each new version of an agent, you want to understand where did it regress in its quality conversations and where did it kind of move forward. And so what we built today is a way to create a parameterized agent to have a conversation with the agent that you're trying to test, and then to generate a bunch of automated conversations between the two agents, and then to have a third agent review the conversation and grade it across several qualitative metrics. All right, so we're running this face-off now between one agent that's under test and then a parameterized set of agents that have different conversations about travel. And so the agent under test says, where do you want to travel to, or what do you want to do? So these are conversations that got generated, and so one of our agents that tested the agent under test says, I don't know where I want to go, but I want to travel internationally, and I'm traveling with my girlfriend, and they have a whole conversation. You just kind of scroll to the bottom. And then eventually the agent kind of provides an itinerary to them. If you want to look at the other conversation. And there's another one, and this one is testing, it's a woman saying she's planning a bachelorette party for 11 other women and kind of what they're looking for. And so that's the idea of parameterizing it, so each, you're testing it in a lot of different ways. And then if you want to show the scoring. And then this is just a scoring interface. So we asked a third agent to review the traveler satisfaction, how much the traveler thought they were having a conversation with a human, whether they talked about the age of the travelers, in which case it scored low on that, and then what was the quality of the itinerary presented for what the travelers expressed their preferences were. And then the framework allows for just adding many more different criteria that you might assess your conversations against. That's it.
What's the meta eval? So how do I know that the evaluation is correct?
How do you know that the evaluation?
For example, are any of the itinerary judgments?
Oh, sorry, yeah. So
on the track analysis. Is the itinerary actually worse?
Yeah, so in this case, it's also providing some qualitative feedback as well. So it says the traveler did an excellent job of understanding their preferences, suggesting destinations that align with them, creating a unique blend of wine tasting, vibrant nightlife, and spa relaxation. So that's a way you can kind of review it.
Well, can you do like zero or like few shot learning where you can give it, like if you see that their evaluation is off, can you adjust the evaluation framework? Like, do you do any tuning of the evaluation framework with like few shot?
Well, we're also doing a lot of human review of conversations, and so this is an idea to like point human reviewers at areas that it feels like it's not doing as good of a job. So it's kind of like, you know, even if you do automated testing in software development, you still do other types of testing as well. This is a way to do automated testing on all the things that we feel like are detectable well by the evaluators, and we still do human testing.
Okay.
Thanks.
Olivia.
All right. Hey everyone, we're a team of AI researchers from UC Berkeley, and we were trying to tackle a problem that all of us have run into. And the problem is that when you read a paper, there's a lot of very important information about the paper that's not in the text of the paper itself. So this is questions like, is the method still STOTA? Are there limitations that weren't discussed in the paper? Like, did the results even replicate? And so our solution is to build an AI assistant that can give you a summary that doesn't just include the content in the paper, but it can also look at follow-up works and give you a summary that kind of describes how the follow-up works talked about the paper you're interested in.
Sure, yeah. And I'll just start running the demo while I'm talking and explain what it does. We're pushing the limits of network performance here. It's transmitting hundreds of bytes per response, so it's going to take a little while. But what it does is you put in an archive URL, it will like download the thing, it will use GPT to summarize it, come up with like a templated summary kind of thing. And then it like chains through all the papers that cite this paper. It does some re-ranking using LLMs to figure out which are the most relevant. And then for each of those most relevant papers, it extracts the key points like, what do these follow-up papers say about the original paper that wasn't in the original paper? Like, what have we learned since the original paper was published? And given those summaries, it synthesizes those into like a single meta-summary that tells us all the like interesting new things about the paper. Like, here we gave it this reinforcement learning paper that was from a few years ago. It's doing reinforcement learning with contrastive learning for environments with like pixel input. And one interesting thing about this is that shortly after it was published, there was another paper that was published, or a series of papers in fact, that were like, you don't need contrastive learning, all of the like juice from this method is coming from just using image augmentations, and hopefully we'll see it figure this out on its own. Almost suspenseful.
Do you use a Google Scholar, or how do you look at models?
No, we're using a thing called Proof in our scraping. Yeah, so it summarizes the original paper using the template that we gave it, and then it summarizes a bunch of related papers, and does it. Yeah, and the important thing here is that it identifies this later paper that showed that you don't need the contrastive stuff, you just need image augmentations, which is pretty useful.
I'm feeling very excited about this. I wish I had this when I started doing research. Of course, we had only a couple of hours today to work at this, so there are a lot of possible improvements and extensions. Here we're only scraping archive. A lot of times, a lot of insights and discussions come from Twitter, for example, could be another source of scraping. And of course, a large language model could also figure out what papers are even more relevant and start digging even more into them, not just looking at a summary. Then we could also make interactive. You want to have like interactions with the users that could tell you, like, oh, this is actually more relevant for that comparison, or this other thing is a bit less relevant, and so on. And of course, you want to have direct links maybe to the original papers where you could look where and how the conclusions were taken for drawing the summary. Again, summarizing, very excited about this. Happy to hear your feedback.
Congrats. And this one question, how do you re-rank the future citations for relevance? What model do you use for that?
Yeah, so essentially what we do is we use like a third-party website, Profi is the name. What we do is we query the URL of the archive that we give and see like what papers are cited this paper. Then we kind of rank them first, like look at the citation count usually. That gives an indication of how relevant they are, but then we query a large language model for each of these ranked papers to understand whether there is actually some relevance. Sometimes, you know, for example, in this paper on reinforcement learning, one of the top cited papers was about COVID. I'm not sure why. Of course, this is not very relevant as a direct comparison, although you know there might be some links. So that's what we do as a second step to filter out.
So the re-ranker that's not citation based is an LLM that takes the text of the title? Or
Yeah, the first step ranking is citation based, and then there is a filtering step that's done by the LLM. Yeah.
What's its problem?
Is this we give like title and abstract for both papers and say are these papers very related or not?
aindex.ai. Show me how you create reusable AI functions.
Hi, I'm Eduardo. Well, yeah, we connect. So I do research in AI for medicine at Stanford, but I like doing studies outside of medicine. So I'm now very interested in the functions from OpenAI, as everybody here probably. And I'm interested because I'm building a directory for plugins. So you can find all the plugins here and you can install them using an open source library. And here you can automatically build the prompt for the plugin. But now I want to exchange this for functions. But who here played with functions? It's a little bit tricky. So Amjad was playing with that and tweeted that it's a bit tricky and hard to play with that. So it got me thinking if we could make some reusable functions inspired on Voyager. So that's why I had the aindex.ai. So the idea is just to build a repository on GitHub, like a lot of repositories for a lot of things, and make it easy to use functions based on this idea and the Voyager and Jeremy pitch today as well. So the idea is just for you to put a function there, you give this a name, it needs to be a unique name, and you import a index as a, and you just use the name of the function to put this on the OpenAI call. So you come from this description to this function, and you can use that if you want to make it public. So for this, I just make a repository. You can go there by just typing aindex.ai or using this QR code. And the idea here is to make it very, very, very simple. So this notebook is an example that you can find there. You just pip install aindex, and you import aindex as a, and you get current weather. You can see that you get this, and when you call OpenAI with this function here, let me make it bigger. So instead of defining that huge function, you just call get current weather. So thank you.
Is it easy for the model to take advantage of these functions in their shorter form? And how do you think we should represent these functions to the agent so that it's much easier for them to take advantage of?
I have no idea. let's find out.
Yeah, I'm sure General Voyager knows.
Yeah, there are a lot of repos for agents, to define agents, to define other things. So yeah, let's figure out.
Okay, let's hear it for ANS. Okay, postcard game, you are up.
Okay, so hello everyone. My project is called PostCardGenie. It's an AI agent designed to help you create customized postcards and send them to your fans instantly. Some introduction about myself. My name is Frank, and currently I'm working on this project. It's called aindex.ai, which is a platform that can help you add AI assistant to your product just in minutes. Okay, now back to PostCardGenie. Let me show you how this agent works. You plan to send a birthday postcard to your friend, and all you need to do is just PostCardGenie. All you just need to do is let me restart first. Okay. Okay. All you need to do is just say happy birthday. Okay. Happy birthday. And then it will using the GPT to generate content and image. And then a message with unique postcard is ready for you to send your friend via SMS with the content and a unique image. If the network is ready. Yeah. Okay. Yeah. Also, I prepared for video. Okay, let me show the video.
So 1 moment.
Happy birthday. I'm sorry, yeah. Not only the video but also the product is also response. It will generate a context, a text for your friend and wish he has a happy birthday, and with a link. It's let me input Tom, send to Tom, and it will with a bit.ly link with the happy birthday card. Yeah. It's unique image generated by the OpenAI. Yeah. So because of the time, this is only a quick demo for how this agent works. We can make the PostCardGenie smarter to support more messaging channels and customize choice in the future. Thank you.
I have a question for sending your friends generated postcards.
Any question?
Okay, thank you.
Okay, thank you.
One quick question. So image generation is API based.
Yeah.
What API do you use?
DALL-E of the OpenAI.
I see. Yeah. Are you happy with it, or do you think it's ideally something better?
It should be better.
Okay. I guess that mid-journey API is very
Yes.
Never gonna do it.
Yeah, I can show you some of the other photos they just generate. Yeah, and all this is this afternoon I generated this.
Oh, okay. So these are all DALL-Es?
Yeah, all DALL-E. Yeah, it's the correct one.
Yeah.
Thank you.
Okay, so yeah, Jungle Gym, you're up.
Great, awesome. So just very quick, basically, who is familiar with the ImageNet time? Basically, 2012, that's when we learned that neural networks would work, because there was a benchmark. The benchmark was called ImageNet, and that's when AlexNet basically did much better than other benchmarks. We don't have that today for agents, and that's a problem. We have all these agents just operating in the wild, but there's no way to measure them against each other and learn from certain improvements from each other. So basically, the idea of Jungle Gym is do that. This is the AlexNet time. That was the time when we all started working on it. So for instance, Budger, we have Jim here, and he was talking about his paper. It's super interesting that not a lot of people had paid attention to what happened in that paper, but there were 3 key concepts that actually could be applied today to AutoGPT, Baby AGI, or any other agents that actually could perform so much better. One of them was the automatic curriculums, a really high quality curriculum generated by GPT-4. The second one was the skill library, and that's like a super important thing. The third one was the self-verification. If you implement those 3 things, automatically your agent performs so much better. The purple line is AutoGPT, just to give you an idea. And AutoGPT is an implementation of React, which is a very simple concept. So basically the idea, and this is what I worked on today, is create the agent, and oops, let me speak that. So basically this is the playground. We call it Jungle Gym, where basically you can select your data set. In this case, Mind2Web, we talk about Mind2Web, is probably the largest data set right now of labeled data from real websites. There's other ones, there's other 2, Web Shop Center 1, and MiniWO, which is for mobile websites. But we can just select here, for example, Mind2Web. So I loaded already the data set, and you can actually see the entire data set, how it's formed. It's basically primarily in travel, shopping, and entertainment. And you can see all the options over here. And you can just see even which websites they use for labeling. So there's NASA, there's Amazon, there's Kohl's, etc. And you can actually filter it out by task. So if you want to test your agent, so if you have AutoGPT, Multi-On, whatever, you can actually benchmark both of them and have those learnings and implement it. So you go and select here the field you want to do it, the subdomain, and then you can now select over here the agent you want to test. So you can do AutoGPT, Baby AGI. So one of the things I'm working on right now is, Project was with Minecraft, but now we need to do it for web. And now because we have longer context windows with 16K and 100K with Claude, so I'm working on building those so that we can actually have a Project web GPT. And that's basically it. It's basically Jungle Gym. Thank you. Yes.
I really love this web Voyager concept. So, like, have you started the code base for that? Like, what's the action space like? Like, how are you defining those HTML interactions? Is there pre-processing, etc.?
Yeah. So right now, the Mind2Web basically has 2,300 annotations entirely from the home page all the way up to the finished task. So, for example, if it's on United website, so you have there you select buy me a ticket from San Francisco to LA to house the entire sequence. And the way it does it is they train a specific model, they train Flan for chunking what are the most important things of the HTML. To know like this is where you need to click, this is where you need to type in LA and so on, and you can just keep going over there. So right now, the idea of doing the implementation with Moiead is doing exactly that with the addition of the skill library. So maybe you become actually really good on booking flights or filtering spam, but you have now that skill library because you're learning from a lot of websites. I would say like the next logical step for me to do is train like Falcon 40D on this website. I'm sorry, Mind2Web basically, or any of these models, Llama or something.
Follow up if there isn't another question. Is the bottleneck at the pre-processing step? Like, are preprocessors unable to fetch the relevant UI actions for these websites? Or is it that once we have those UI actions, we can't reason about them effectively to perform some pre-process tasks?
I think the main bottleneck has been so far, and we might have ways. First one, there was no benchmark, there was no data set out there so that we can benchmark these things. Like all the models are just the wild. That's the first one. I think that's a problem. Second one is the context window was just not, even like the 4000 one was not enough for having the whole page. So that's why they had a second model do that. But now, if you have the 16K with GPT 3.5 turbo, that's actually enough to fill the window or with Claude. Yeah.
Thank you.
Incredible. Yeah. Thank you.
Okay, and last but not least, a Replit demo, a ghostwriter agent, full app creation.
Okay, I can entertain people out of me a little bit. We have the Replit team, as you know, the 3 people out of what, 80 currently? So, perfect, we made it. Okay, so I've seen a bunch of you using Replit today. Thanks a lot if you have feedback, come to us later. But as you know, our company mission is to create the shortest path between an idea to a functioning demo. And we're trying to make that happen also thanks to AI, to reduce the time it takes you to come up with a brilliant idea and have the first piece of software running. So we're going to start by showing you what we integrated in Ghostwriter in the past few days. When you go and try to create a repo, rather than just choosing the language you want, you come up with a natural language description. So like here we have content for game in Python. We understand from the prompt that you want to create a Python application, so we automatically filter and select for you the Python template. If you use templates, basically, you know that it's a way for you to have a scaffolding where to start from in an application. And in this initial demo, we just called GPT-4 and asked to create basically one file with the skeleton of the app. I think we have a problem with the Wi-Fi. No, perfect, it's working. Okay, so that's where we stood until basically yesterday night. Then we came here, brought lunch, and after putting lunch around, we said, okay, you know what, we're gonna go in a room and start to hack. So we wanted to go from this initial prototype into something that actually integrates an agent. So let's go to the next one. And here's what's going on. So on the left side, this is all running in this laptop right now, but we took a video because the Wi-Fi is very spotty. So on the left side, you're going to see basically the backend, and on the right side is the current localhost integration that we have at the agent. So what we do here is start it. Perfect. So the backend is starting, and now we have our Ghostwriter is, in case you never use Replit, and you should, it's our chat agent that basically helps you to go ask questions. But here we do something slightly different. I shouldn't step in front of the projector. So what we do here is we have an initial prompt. We say create an image size reducer program. And now we already integrated an agent that exists in the open source community. We hacked around it, we built a backend in front of it and did some improvements. But the key insight is we're asking you for additional clarification. So we start by generating a plan, and at each step of the plan, we're asking you for what exactly you want. So for example, we're asking what kind of language do you want to use to build this image reducer, what is the input format, what is the output format. We can skip this because I don't think anyone is going to get excited about it. And then you get patient because again it's GPT-4, so you gotta pay some patience and put your credit card, maybe skip forward. And what's going on here compared to before is it's gonna start to generate each single file that you need. There we go, it's running. And all the files will be materialized into your file system. You can just run the application. I think we went with this odd idea of resizing a Michael Fassbender image, right? I think it's a famous actor who did 300 and some other fancy movies. Let's show that it works. Yeah, it also creates the dependencies, as you can imagine, so we're just installing them. And in the 30 seconds, you will see that it works. Okay, so this is the high level. So we wanted to go from something that just generates code into something that gives you all the different flags of an app. And I think the next step for us is to add self-critique. So we want to make sure that each single file that we generate, the user can give us feedback if there is something wrong, and we generate them on the fly. And the dream is they don't have to run a single line of code. That's all. Thank you.
Generate the code in like a one-shot pass, or do you do like a sequential iteration?
Right now we're doing one-shot pass, and the next thing we want to do is, given that now we materialize the files on the file system, then we're going to do basically one self-critique step per file.
Got it, but you can generate like multiple files at once, right?
Yeah, you can do that, and basically we capture the structure output from GPT-4 and get the file name recommended plus the word content. And for relatively simple apps, as you know, it works pretty well.
Do you want to judge what the complexity level of the project that you can auto-generate is?
What is the complexity level?
Yeah, so for example here, it's about kind of compassion or something wrong. But for example, maybe hackathon projects, like which of them can and cannot be ghostwritten?
So we can do relatively simple web apps, which is more than what we're showing right now. The reason why we didn't do that is because it creates like a complex hierarchy in the file system, and we literally finished this half an hour ago. But like you can bring up like a Flask application with a couple of forms just by writing the revision. More than that, it's what we want in our vision in Replit, so it's going to take us maybe 6 months or so to make that happen, where you can build something more advanced. But for most of the simple use cases, we're there.
Any other questions for folks here? Round of applause.
Thank you.
Okay. Thus concludes the creation of some 30 new agent projects. A huge round of applause to all of you. The person with the eyes next to you, pat them on the back, shake their hand, while we wait for our judges to deliver the final conclusion.
By the way, guys, I just want to say one quick thing. A big round of applause for Jeremy for doing an awesome job. It's awesome as a host.
Hey, is everyone ready to hear what us judges have decided on? So if you just have a minute, and then I know we're all tired, it's late, and appreciate everyone being here. So we were torn. There were so many amazing projects tonight, and a lot of people hacking actually in similar themes, so it was tough to choose, but we went across the entire judge base, we looked at the code that was put together, the business use cases, and just overall how kind of impressive the demo was. We actually had 3 teams that we're going to pick, but we also loved some of the dating use cases, and we're going to have an honorary shout out for that one. And in terms of prizes, we're going to have each team kind of take home 3 of these gift boxes that we put together with a bunch of lovely swag. So hope that's a good prize. So we'll start out with the honorary prize of the night, and I would love for the Sparklings team to come up because we all loved the dating project that you guys have put up together. So I don't know where the Sparklings team is, but come up. Yay, everyone give them a round of applause. Please take, how many, you guys 2 people?
Actually, one that's already.
Oh, take 3.
Okay.
Yeah.
Oh, you don't have. We can just take 2.
Okay, take 2. Perfect.
What's your size? Feature size. Medium?
What?
Medium size.
Oh,
Feature size.
Small?
Awesome, amazing job. Looks like you're gonna get a little multi-on prize. Gifts. So much swag.
Nice.
Amazing. All right, congrats to the team. So in third place, we thought long and hard about this one. A lot of folks that worked on more research-oriented projects, a lot of co-pilot-esque type stuff. We ended up loving what the team from Agent Arc put together. So if you guys are here, the folks who built the multi-agent system for clinical trial automation, please come on up. We have a ton of prizes and we'd love for you guys to come.
Bigger team.
Yeah, like most of them went home.
Would you like to take 3 boxes for your team members, or you can just take one for yourself? It's up to you.
I will see at least one of them in South Base.
Okay, perfect. Let's go.
Alright.
Awesome. That was more t-shirts. All right. So for second place, we cheated. It was, again, so hard to pick amongst the projects. So we had 2 tied for second places amongst the judges. In no particular order, I will go alphabetical order here, but in second place, we loved what the team from Next.ai put together, your AI front-end dev. So if the team is still here, we'd love for you to come up and pick up some boxes. Yeah. Thank you guys for...
Cats for the win.
Exactly. Yeah.
T-shirts. What is that? Launch or? Thank you.
All right. And also, applause for the team. Also coming in second place, because we had a hard time choosing, the one-man show from Express AI, who hacked using an AI agent Discord bot using the multi-on plugin, is Eduardo here.
Yeah.
Yay! Impressive. All right, and the moment I know we've all been waiting for. Number 1, it was actually a pretty unanimous vote across the judges for this one, but will the team from Agents Eval come up and the large team? Please come up and claim your prize. We have a lot of boxes up here for you guys. Congrats on winning. Before you pick up your boxes, I don't know, any words of wisdom for the crowd? And a photo with maybe judges. Can you take a photo? Okay. Yeah. Are we on with it? Perfect.
Jeremy, do you want to?
It's a little tricky with the... Okay. Oh, okay. Okay. All right, everyone ready?
Thank you. Victory speech. Yeah, I mean, I think it's just a really important problem, and so, yeah.
We'd love to work with other people who want to solve this. We're thinking about open sourcing what we were thinking about, and I saw Marco and many others working on it. So we'd love to talk to other people. And I know we started our presentation with agents suck right now, but they don't. They're awesome, and like there's a long road for us to do cool stuff. So yeah, it was amazing to hack with everyone today.
So we are all t-shirts, but we have a sample model, and we will have to open it up.
Wow.
Yes, it's like yes. Spray the crowd. Is that
No one wants to open it.
Thank you.
All right. Yeah. Congrats, guys.
T-shirt.
Yeah,
T-shirt.
And with that, I would like to end the Agents Hackathon with chorus after chorus of applause. So first to our wonderful sponsor and our judges. Second to each and every co-host and all the speakers who made this event incredible. Thanks so much. last but not least, the hackers. The people in this room, you guys are all incredible. It's been a joy to spend the last 10 hours creating all sorts of incredible stuff with you. Much love.
Also, Jeremy, the guy who made all this happen. Thank you.
So this is not the end, this is merely the beginning. We're going to be hosting epic hackathons for months to come. And so if you have creative instincts, do let me know. I'd love to run a hackathon with you all. And I would love to invite you and everyone who you know are great hackers to the house to do amazing things from now on. So do let me know if you have ideas. Do bring your best hackers. And do spend the rest of the night engaged in enthralling conversations about the future of AI and this moment in history. Places you can have it.